Hi there. Today we're going to discuss compare and order rational numbers. I would like to have you guys turn to page 272 in your books. I'm going to go through examples 1 through 5 from page 272 and 274. So what are we going to learn today? We're going to learn to compare rational numbers, and then we're going to order rational numbers. Vocabulary you need to know for today is rational number, common denominator, and least common denominator. I hope you guys took the time out to write that down in your vocabulary. Here's example number 1. It says fill the circle with less than, greater than, or equal to make -1 5/6 circle -1 1/6 a true sentence. So here we're going to graph each rational number on a number line. You're going to mark off equal size increments of 1/6 between -2 and -1 because both of these numbers are between -2 and -1. So when we go ahead and do that, we'll notice that -5/6 is to the left and -1/6 is to the right. So when we do that, the number line shows that -1 5/6 is less than -1 1/6 because this number is to the left. And remember, whenever you're graphing, numbers that are to the left are considered less than the numbers that are graphed on to the right. Okay? Here's example number 2, again on page 272. Fill the circle with less than, greater than, or equal to make 7/12 circle 8/18 a true sentence. Now here it becomes a little difficult because these two have unlike denominators. So whenever you have unlike denominators, it's very difficult to compare them unless they have the same denominator. So our first thing we're going to do is find our least common denominator. So our least common denominator of 12 and 18 is 36. So what we're going to have to do now is we're going to have to change the fractions with a common denominator. Okay, so how do we get from 12 to 36? We would multiply the numerator and denominator by 3. How do we get from 18 to 36? We multiply the numerator and denominator by 2. So just again, really quick, make sure that when you're changing these fractions, the numerator and denominator changes for both of them. So 7/12 end up to equal 21 over 36, and 8/18 equals 16 over 36. So now you can see they have the same denominators, and all you have to do now is compare the numerators. So since 21 is greater than 16, 7/12 is greater than 8/18. Example 3. In Mr. Huang's class, 20% of students own roller shoes. In Ms. Trevino's class, 5 out of 29 students own roller shoes. In which class does a greater fraction of students own roller shoes? So here, they're giving you these statistics, but they want you to find out who has a greater fraction. And in both cases, neither of them are fractions. So what you're going to have to do is create fractions for both of them. So you're going to express each number as a decimal and then compare. My recommendation is if ever you have fractions that you're comparing, it might be easier to turn them all into decimals because decimals are easier to compare. So 20% is 20 over 100 or 20 divided by 100. That equals 0.2. 5 over 29 is the same thing as saying 5 divided by 29, and that's just about 0.1724. So when you compare them, 0.2 is greater than 0.1724. So let's come back to the original forms that they have in the sentence. 20% is greater than 5 over 29. So more students in Mr. Huang's class own roller shoes. Here's example number 4. Order this at 3.44, pi, 3.14, and 3.4 repeating from least to greatest. Now here we have some terminating decimals, we've got some irrational numbers, and we've got some repeating decimals, okay? And notice that they all don't have the same amount of decimal places. So what you're going to have to do is line up the decimal points and compare using place value. So we have 3.14, pi is 3.141596, and on and on and on. 3.44, and then 3.444. Now, when they say nx is 0, that basically just means that they want you to have the same number of decimal places so you can compare them. Okay, so here we have, since 0 is less than 1, we have 3.140, and then next would be 3.141, then 3.440, and then 3.44. This one repeats forever. So by lining up all the decimals from least to greatest is 3.14, then pi, 3.44, and then 3.4 repeating. Okay, see, these two had the 1 and the 4 the same. So if you moved on to the next decimal place, 0 came first, and then this 1. These 3.44s were the same, but because this is a terminating decimal, you can add zeros on forever. 0 is less than 4, so that's why that goes third, and then this goes fourth. Example number 5. Nolan is quarterback on the football team. He completed 67% of his passes in the first game. He completed 0.64, 3/5, and 69% of his passes the next 3 games. List Nolan's completed passing numbers from least to greatest. Okay, again, we have all different forms here. We have percents, we have decimals, and we have fractions. My best advice to you is put them all to decimals because they're easier to compare. So express each number as a decimal and then compare. So 67%, 0.67, 64%, 0.64, 3/5, 3 divided by 5 is 0.6, and 69%, 0.69. So all you have to do now is take these decimals and start comparing them. So the first one that we have in line is 3/5, 0.6. Then we have 0.64. Then we have 0.67, and then 0.69. So what you want to do is put them back into their original form from the problem. So 3/5, 0.64, 67%, and 69%. Okay, hope that video was helpful. Thank you. Bye.